All right, so this section is about solving polynomial equations that are in factored form. And believe it or not, you've already seen polynomials that are in factored form. That's what they look like before we multiply them. Remember, we've talked about factors several times before. When I have a multiplication problem like 4 times 7 equals 28. Remember that the answer to a multiplication problem, that's called the product. But then each of these two things that we're multiplying together, those are called the factors. So anytime we talk about factors, we want something written as things that are being multiplied together. Okay, so if we look at this table here, the first column are polynomials that are in standard form. They are written as a sum of monomials. I have x squared plus 2x, for example. And they are written from the highest exponent down to the lowest exponent, so we know that they're in the correct order. Standard form is like, it's basically, if you think backwards to the multiplication problems that we've done, it's kind of like in Jeopardy where you get the answer and then you have to come up with the question. Standard form is the answer to your multiplication problem. Factored form is what it looks like before you multiplied it out. So all of those problems that you had on your multiplication work, those were polynomials that were written in factored form. And so, for example, in the first one, if I were to distribute this x, I would get x squared plus 2x. And so that is kind of what factored form means. Now, we've already talked a little bit about the idea of the zero product property, but this is a really kind of important thing when we are solving polynomials. And what it says is that if the product of two real numbers is 0, then at least one of the numbers has to be equal to 0. And this is kind of what we talked about in class. If I have some number times some number, and I know that the answer is 0, the only way that I can multiply two things and have my answer be 0 is if either this one is equal to 0 or this one is equal to 0. And so we can kind of see that when we write this out using algebra. If a times b equals 0, then either a is equal to 0 or b is equal to 0. That's a fact. And so using that fact, we can solve equations when they're written in standard form. Now, because of the zero product property, I have to know that a times b is equal to 0. So you'll notice in both of these instances where we're solving that we have to have our equation equal to 0 on one side. If it's not equal to 0, then it's not going to work. There's no way we can be certain what one of them is going to be. So in number 1, I have two factors. I have 2x and I have x minus 4. So that's sort of like this was our a and this was our b according to the rule in the box up above. So what that says is if 2x times x minus 4 is equal to 0, then one of two things is true. Either 2x equals 0 or x minus 4 has to be equal to 0. And now those are two equations that we already know how to solve. So on the first one I can divide by 2 and we get x is equal to 0. So there's one possible solution. Over here we can add 4. So that means x is equal to 4. So when we solve this, we had two factors that contained variables. That means we get two possible solutions for our equation. Number 2 is very similar. Here's my two factors, x minus 3 and x minus 9. So again, that means x minus 3 equals 0 or x minus 9 equals 0. We can solve these equations pretty easily in our head. Add 3 to both sides, I get x equals 3. There's one. Add 9 to both sides, I get x equals 9. There's the other one. Okay? There are a couple of examples below for you to try. And so go ahead and try those out. You can bring those to me when you're done with your notes. Something else that's important is to realize that sometimes you can get a solution more than one time. When we do, those are called repeated roots. Now, in these examples here, only one of them is going to be a case where we get a repeated root, and that's going to be number 6. One of the things that we looked at before was the idea that when I have something squared, that means multiply it by itself. So I have b plus 7 times b plus 7 equals 0. Well, I'm going to end up with that same equation 2 times. Either b plus 7 equals 0 or b plus 7 equals 0, but that's going to give me the same answer. So we don't have to repeat ourselves. We just only need to put it once. And then negative 7 would be called a repeated root because there are 2 factors that give me the same solution. It's repeated 2 times. Okay? Now, on number 5, this is not going to give us a repeated root. We can tell because these 2 factors are not exactly the same. But these are a little bit trickier equations. They have more than one step. That doesn't mean that we can't do it. It just means we're going to have to do a little bit more of a process here. So on the first equation, the first thing I would do would be to subtract 5. So I would have 3x equals negative 5. And then I'll divide by 3. 3 doesn't go into 5, so that means that we get a fraction, and negative 5 over 3 does not reduce, and so there is our first solution. You can kind of predict we're going to get a fraction on the second one as well. I get 5x equals negative 8. When I divide by 5, it doesn't divide or reduce, so we get negative 8 over 5 for our second root. The last one, number 7, looks like it's going to be hard, but since there's 3 factors, that just means that I have 3 possible solutions. So instead of 2 equations, I'm going to write 3. D minus 2 equals 0, D plus 6 equals 0, or 3D plus 8 equals 0. So we get D equals 2, one solution. D equals negative 6. There's our second solution. Over here we have to subtract 8, then divide by 3. So we get negative 8/3, and that is our third solution. Notice we had 3 factors. We got 3 solutions. And so that is really the big idea here. And that is where we're going to stop for today.